All right, ladies and gentlemen, homework out. Let's run through it. It's just 1 through 9, wasn't it?
Yeah.
Great. So if you're here, you're getting credit. If you're not here, well, make it up. 151 was it? I think that's right. 151, is that right?
Yes.
Here we go. All right, let's run through these. Let's see. Problem number 1, we have 7x squared plus 23 is equal to 100. Everyone feel comfortable that we're missing the b term? Does that make sense?
Yeah.
So we could go and try and use the quadratic formula on this as long as I made it equal to 0, right? Or I could probably go about doing this. I could probably say, well, let's subtract 23 from both sides. Those cancel, so I get 7x squared is equal to 77. And then 7 times a quantity, well, let's undo this, divide each side by 7. Bam. X squared is equal to 11. What do I have to do to both sides? Square root it. What should I not forget? Plus or minus. So my answer is x equals plus or minus the square root of 11, which is a little bit bigger than 3. Is that okay?
Yes, it is.
Sweet. Problem number 2. Problem number 2 says, oh, this one's a little more complex. Uh-oh. Okay. I think we might be able to work through this. So, minus 3 equals 61. All right. The thing I want you to stay away from on here, and a lot of students are going to do it because you're like, oh, parentheses, number in front, distribute. Yeah, but the quantity is raised to the second power, so you can't distribute on this until you took care of the x minus 7 and x minus 7 multiplied. Okay? So let's get the distribute out of our head. So let's start trying to solve this. Let's see. I can add 4 to both sides. What do you think? Or, excuse me, add 3 to both sides. To get that, what do you think? Make sense? So I have 4 times the quantity, so how can I undo that 4 times the quantity? Division. Good. So I'm going to divide by 4, divide by 4. So I'm going to get x minus 7, quantity squared, equals 16. Is that right?
Yeah.
Okay. Now I can undo this squared quantity. What should I do? Square root first. What don't I forget? Need the plus minus. So I get x minus 7 is equal to plus or minus. What's the square root of 16? 4. Okay. Add 7 to both sides. So I'm going to get 7 plus or minus 4. So 7 plus 4 is 11. 7 minus 4 is 3. So there's my 2 answers. If I had graphed this as a quadratic, wanted to make the parabola, it would cross on the x-axis at 11, 0 and 3, 0. Okay? Number 3, we have 9x squared plus 36 is equal to 117. Is that right? So I guess I could make it equal to 0 by bringing the 117 over by subtracting it and then plug into the quadratic formula. Or I'm missing the linear component. I'm missing the x component. So if I subtract 36 from both sides, those cancel. So then I have 9x squared is equal to 81, I believe. Did I do that right? I hope so. This is because it'll work out really nice. So how do I undo 9x squared? Divide by what? 9. Good. So 81 over 9 is what? 9. The square root, what should I not forget? Plus or minus. So I get x squared is equal to plus or minus, what's the square root of 9? 3. Okay? Number 4, I have 2x squared plus 7x plus 6. I think this one might factor. What's my magic number? 12? Agree? All signs are positive, so both of these have to be positive. What factors of 12 add to 7? 3 and 4. Does everyone agree with that? Oh, man, he's bringing the factoring back? You kidding me? All right, 2x squared plus 3x plus 4x plus 6 equals 0. I have an x in common here, so that's 2x plus 3. I have a 2 in common here. So this is going to factor down to 2x plus 3 and x plus 2. Set both those equal to 0. Subtract 3, divide by 2. There's one answer. Subtract 2. There's my other answer. If I had used the quadratic formula on it, my answers would be the exact same. But sometimes it might be faster to go through if you can see it factored quickly. Agree? So on the quiz tomorrow, you might see something say, hey, factor to solve. Well, if you're panicking on that, then use the quadratic. You can't see setup, or I'll see your setup will be an error, but it'll still get you 3 out of 4 points on a problem. Okay? Number 5. We get 4x squared minus 25 equals 0. Anything special about this one? There's no b value. Good. What is it? It's equal to 0. Quadratic formula could work. Is 4x squared a perfect square? Is 25 a perfect square? Is difference for another name for subtraction? What is this?
Difference of 2 squares.
Difference of 2 squares. So this is the difference of 2 squares. So this will break down to 2x plus 5 and 2x minus 5. Well, set them both equal to 0. Okay, subtract 5, divide by 2, add 5, divided by 2. So I get negative 5 over 2 and positive 5 over 2. If I use the quadratic formula, I'd get the exact same answer. Well, which way should I do it? Well, if the directions tell you to solve it by factoring, they're looking for the difference of 2 squares. If you're like, I'm just using the quadratic formula, great. You miss one setup point, but then you get the rest right if you do it correctly, which is kind of cool. Can I go to number 6? Chi. Number 6. X squared minus 6x is equal to 2x. Is this set up for the quadratic formula? It's not equal to 0, is it? So let's bring the 2x over. So by bringing the 2x over, it means I'm subtracting it. So what's over here now? Negative 8x. So I guess I could use the quadratic formula, knowing that a is 1 and b is negative 8 and c is 0. Or I could realize, oh, I have a factor here of x. So x minus 8 is equal to 0. Don't go redistribute. We just undid it. All right, so this is going to give me x equals 0. And this is going to give me x equals 8. Done. Use quadratic formula, same answer. May I go to number 7? And these are finally asking for the quadratic. Ready? 7? 2x squared plus 5x equals 8. Is this ready for the quadratic formula? No, it's not equal to 0, so how do I make it equal to 0? Subtract 8 from both sides. Good. All right, so I know that my A value is 2. I know my B value is 5. And I know my C value is -8. And we know that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. All right, what color is B? Red. So I get -5, right? And then I put a 5 here. Do I use B anymore in my quadratic? That's A, that's C, that's... Okay, what color is my A value? Black. Okay, 4A, C all over 2A. And then what color is my C value? Green. The blue is all just the normal setup of the problem, agree? Alright, so let's start working this out. So I get -5, still it's x equals still, plus or minus 5 squared to 25. -4 times 2 is -8. -8 times -8 is?
64.
Positive 64. Do you see the sign change? All over 4. Agree? It's still equal to x, so I get -5 plus or minus the square root. I think that's 91. Is it? What is it? 89? 89 over 4. Does 89 break down? Let's see. 4. I don't think 4 would go into it because it's an odd number. Would 9 go into it? Well, 9 times 9 is 81. 9 times 10 is 90, so no, that's not going to work. 16 is not going to work because, again, it's an odd number. Ooh, 25. No, 25 times 3 is 75. 25 times 4 is 100. No, that's not going to work. 36. 36 times 2 is 72. No, it's going to be too big. 49. 49. There we go. 49. 49 times 2 is 98. 64? No. 81? No. I think we're done. This is my exact radical answer, right? Cool. I like it.
Use force.
Wouldn't that be awesome if it was like, whoop? All right, number 8. Number 8. Number 8. X squared minus 4x minus 3 is equal to 0, right? Is this set up for the quadratic formula? Yep. So x is equal to -b. What's b? -4 plus or minus the square root of b squared, which is -4 squared, minus 4. What's a?
Was that positive?
1. What's c? All over 2a, which is 1. Okay, so that's, I'm plugging a negative in though. So I guess right here is the positive, right? Right there, this part, that gives you 4. It's still x equals plus or minus the square root. What is -4 times -4? We all know it's going to be 16. Even if your calculator tells you it's -16. All right, -4 times 1. -4. -4 times -3. Positive 12. All over 2. Okay, so I get x equals 4 plus or minus, add those together, that's what, 28? I think 28 is going to break down to 4 times 7, which is going to be 2 root 7. Where do I put that 2 root 7? After the plus minus, it totally replaces the root 28, right? Yeah. What?
Wait, could you, so
Up here?
No, just after you split 28 up, you go square root 4 times 7.
Uh-huh.
So then you find the square root of just 4.
Uh-huh, because 7's not.
And then you leave it at 2 square root 7.
So what you're going to do is you're going to replace this with the 28. So you got 4 plus or minus 2 root 7 over 2. And then it looks like I can reduce. 2 goes in everything, right? So I'm going to get 2 plus or minus square root 7. That's what x is equal to. What number was that one? It was 8. Number 9. Number 9. We got 2x squared minus 5x minus 12 equals 0. This is set up already for the quadratic formula, yes? I think it would factor as well, but we'll see. We'll just use quadratic analysis here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative negative 5, positive 5, plus or minus. Negative 5 times negative 5 is 25. Negative 4 times 2 is negative 8. Negative 8 times negative 12 is positive 96. All over 4. Oh, cool. This is going to work out nicely. 25 added to 96 is 121. Anyone know what the square root of 121 is? It's 11, isn't it? So 5 plus or minus 11 over 4. So I get 5 plus 11 is 16 over 4, which comes out to 4. Then I get 5 minus 11 is negative 6 over 4, which reduces to negative 3 over 2. So this definitely would have factored out, but it worked out nicely. Wow. What do you think? Is that okay? All right, so keep that. You get points for it if you're here. And I have some notes. These are kind of quick. These will help you along with the quiz for tomorrow. It's a good place for you to study on these. What? What's your school? Not sure. Didn't hear anything. Just withdrew. I don't know. Maybe went to a different school. Who knows? Maybe moved. All right. All right, so let's take a look. I'm on the side, the very top left says linear. So we have 2x plus 24 equals 16, yes? So I'm on the one side that says linear at the top, over on the far right. All right, linear problem has only one answer because it's x to the first power, agreed? So let's try and solve this. Subtract 24 from both sides. Subtract 24 from both sides, so I get negative 8. Divide each side by 2, so I get x is equal to negative 4. Only one answer when it's linear. It's not squared. Okay? You'll probably see something like that tomorrow.
Quiz.
Uh-huh. Can I move on? Next problem we have right below it says 2x squared minus 18 is equal to 6. Okay, so this is a quadratic. They want us to try and solve it just algebraically. We're not using the quadratic formula. So let's get x by itself. So I think I could add 18 to both sides. So those cancel. So I get 2x squared is is equal to 24. Divide each side by 2. So x squared is equal to 12. Take the square root of both sides. Don't forget the plus minus. So I'm going to get x is equal to plus minus root 12. 12 is going to break down to this, where square root of 4 is 2. Please break it all the way down if there's perfect squares that are part of the number. Could I have used the quadratic on this? Yeah. Your b value would have been 0. Okay, but do what it does. Can I move on?
Yes.
Next one down. X squared minus 36 is equal to 0. Okay? So where do they want you to go with this one? Is x squared a perfect square? Is 36 perfect square? Is difference another word for subtraction? So this is the what? Difference of two squares. So you get x plus 6 and x minus 6 equals 0. So this gives me x equals negative 6. This gives me x equals positive 6. That's it. Okay? Some of you would be like, oh, could I have added 36 to both sides? Absolutely. Then you take the square root of each side. Don't forget your plus minus. Same answers. It's your choice kind of how to do that one. The bottom one says 2x squared minus 8x is equal to 0, yes? Okay. So this one, they want you to factor out the greatest common factor. So what number goes into both 2 and 8? 4. Good try, but it's 2. What's the maximum number of x's I can take out of both of them? Single one. So I factor 2x out of 2x squared, I'm left with x. The minus comes along. If I factor 2x out of that, I'm left with this. So this is going to give me 2x equals 0, which is just 0. X equals 0. And this is going to give me x minus 4 equals 0, which is 4. There's my two answers. You want a silly story before we change the switch sides? They're like, no, just keep doing math. This is so entertaining. You got a story?
Yep.
All right, y'all know the game of craps. It's a dice game. I know you might not know the rules to it, but you realize there's a game called craps. It's a dice game that's played in casinos. Still with me? So, my first year teaching back in '95, the guy teaching across the hall from me, a buddy of mine named George, his brother-in-law came in town. The guy had ridiculous money. I'm not talking like a couple $100. He has a cashier's check for $50,000, meaning he could go to any casino and cash it and get $50,000. He also had about $43,000 or $44,000 cash on him. Okay, so he's not looking for the nickel slot machines. He's not looking for the penny slots. He's not looking for the dollar blackjack tables. He's looking to gamble some big money. So we went to a whole bunch of different casinos. There's me, George, and his brother-in-law. We had a couple of the other teachers that came along. They're just all trailing along. This guy's got silly money. He's getting stuff comped to us. You know, got dinner comped, all this good stuff comped to us all night, meaning it didn't cost us anything. And he's having each of us roll the dice for him. We were like his Lucky Charms or something. I don't know. So we walk into Caesar's Palace, which is a pretty amazing casino. And when you have somebody who's walking around with close to $100,000 cash on them, you don't go in the peasant's entrance. You go into the entrance where it's like, baby seals were slaughtered for the doors, and it's like, 4 elephants were killed for their tusks to open the door. I mean, it was like ridiculous. So we go walking in, like, hey, look at these guys, man, it's pretty in here. Yeah, this is part of the casino we'd never seen because we are not welcome folk because we don't have that kind of money. So this guy's like, hey, stir up. You want to throw the bones for me? Throw the bones in his language was roll the dice. So sure. So we get up to the craps table and just to visualize the craps table. Craps table could be about 17 feet long, 4.5 feet wide. Okay, so pretty big. Neat thing about playing a game of craps, if the person who's rolling the dice is winning, the people all around the table are winning, which is kind of cool. So there's a lot of real cool energy that comes off those tables. So we walk up to this table, and I was like, oh my gosh, there's a woman on the opposite side of this table that's way out of my league. Well, it was Pamela Anderson. Now, if you don't know who Pamela Anderson is, feel free to Google her find her image on your phone. Standing right next to Pamela is her husband, Tommy Lee. Tommy Lee was the drummer for the band Motley Crue. So, me, Pam, Tommy, we're throwing the bones. And I'm like, dude, Tommy, I love Crue. He says, shut up and roll the dice. We had a conversation. Pretty cool. So I rolled the dice. But me, Pam, Tommy, we're talking. It's pretty cool. Pretty cool. So by the end of the night, this guy who had kind of a lot of money on him cashes out his chips. Now he still has his $50,000 cashier's check that he didn't go to. So he's got $50,000 in his pocket, no problem. Cashed out with $243,000 by playing the game of craps.
Did you win?
No, but I got free meals. And all of the sodas we had that night, I had a whole bunch of Coca-Colas. I had 7-Up. I had a few Sprites. They were all free. And the lobster dinner I had, served with a side of baby seal, was really good. I'm just kidding. There wasn't baby seal on there. All right. Let's go to the back side of this page and finish this up. So I thought I'd give you a little silly so you could be like, oh, cool. Do you guys find Pamela Anderson on your phone?
Yes, American Canadian actress.
Yeah. You could probably see how she was out of my league with this full head of hair. Yeah, she wasn't looking. All right. Hey, she was in Baywatch. What do they want us to do on this problem? She is in Baywatch. She's one of the original Baywatch girls. Oh, trinomial. Get it equal. Oh, they want a factor. Okay, so let's get it equal to 0. So 2x squared plus 18x plus 40 equals 0. It appears that I could divide everything by 2. So I'm going to get x squared plus 9x plus 20 is equal to 0. Our magic number is 20, right? Everything's got to be positive. The factors of 20 are 1 and 22 and 10, 4 and 5. Which of those are going to work to add to 9? 4 and 5? So x squared plus 4x plus 5x plus 20 is equal to 0. Let's factor out an x. Factor out a 5. Alright, so my answer is x plus 4, x plus 5. And I have to set each of those equal to 0. So x plus 4 equals 0. So I get an answer of negative 4 for one answer. X plus 5 equals 0. Subtract 5. That's it. That one worked nicely. I like that one. It's the devil. Okay, the next one says, get it equal to 0, then factor. And this one doesn't have a greatest common factor. Okay, I think I can do this. So can I move off this one? We good? All right, 2x to the third, or excuse me, 2x squared plus 3, is that what it is? Equals negative 5x. All right, so we want to get it equal to 0, so I'm going to add 5x to both sides. Yes? So we could use the quadratic formula on this, but it's set to factor. Okay, so my magic number's got to be positive 6. Looks like all the signs are positive. Cool. And the two factors of 6 both being positive, that would add up to 5 are 2 and 3. Agree? All right, so I get 2x squared plus 2x plus 3x plus 3 equals 0. Let's factor this. So I have a 2x I can factor out, so I get x plus 1. I can factor out a 3 here, so it's positive 3 and x plus 1. So I'm going to get x plus 1 and 2x plus 3. Those are equal to 0. So then I'm going to x plus 1 equals 0. So x equals negative 1. 2x plus 3 equals 0. So x equals subtract 3 and then divide by 2. There's my two answers. Bless you. What do you think? Oh, good. Look, the next one says, use the quadratic formula. Yay! Ready? Yeah. Here we go. I got 2x, or x squared minus 2x minus 5 equals 0. Okay, so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So I have the negative 2, which is positive 2. Negative 2 times negative 2 is positive 4. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20 all over 2. 2 plus or minus the square root of 24 over 2. I believe the square root of 24 is going to break up into 4 times 6. Why not 3 and 8? Well, 3 and 8 are perfect squares. So square root of 4 is 2, so I get 2 squared root 6. That's going to replace this right here. Reduce it. So it looks like x equals 1 plus or minus root 6 over 1. There's my answer. Last question. Last question. Ready? I get 4x to the third minus 18x squared equals 10x. It's not a quadratic, is it? It's raised to the third power. All right, so let's get everything on the same side. So subtract 10x. I'm going to get 4x to the third minus 18x squared minus 10x is equal to 0. It looks like I could factor a 2x out of everything. That's going to give me 2x squared minus 9x minus 5 equals 0. Well, this one right here, that's going to give me 2x equals 0, so x equals 0 here. That's one answer, right? How many answers should this one have? It's raised to the third power, so how many should it have? 3, right? So I found one of them. There's 2 left. That might factor, I don't know, but I'll use quadratic. Let's see. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's going to give me 9. Negative 9 times negative 9, we all know it to be 81, even if our calculator tells us it's negative. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is going to be positive 40. Oh, cool. So 9 plus or minus root 121 over 4. What's the square root of 121? It's 11. 11 times 11 is 121. All right, 9 plus 11 is 20, so I get 20 over 4, which is 5. 9 minus 11 is negative 2 over 4, which gives us negative half. There's my 2 answers. All right, so ladies and gentlemen, all my friends, I'm going to give you the exact same sheet, blank. I'd say if you go through this tonight and just work it out, and you have the notes to go along with your page, that might be a good study resource for you. So there is a quiz tomorrow. I would say at the least, go through and work these problems, double check against your notes, or double check against my video. Everyone good?